Hi folks, so the area we're going to be going over today is the area on polygons. It is an area that has to be covered for your junior cycle syllabus. So just a little bit of a background on polygons and what actually makes a polygon. A polygon is a 2D shape, it is made up of straight lines and it is a closed area. So it's 2D not 3D, straight lines so no curves, and a closed area means basically that it is continuously closed, okay, so there's no open sections in it. Now for your junior cert syllabus you need to know how to do 3 types of polygons. You need to know how to do a pentagon, which is a 5-sided figure. You need to know how to do a hexagon, which is 6 sides, and then an octagon, which is 8 sides. And that's what I'm going to be doing today in this video. Just a little demonstration of how you construct a pentagon, a hexagon, and an octagon. We're going to start off with the pentagon. Now, what we are also going to be doing as well is, these are essentially regular polygons. And what that means is that all the sides are going to be the same length and all the angles are going to be the same as well. So for a pentagon they're all going to be 50, for the hexagon they're all going to be 45, and for the octagon you can see here they're all going to be 40 millimeters long. So to do this, what we need to do is first of all do a little bit of maths. Okay, so just on a little bit of maths there, every polygon, regular polygon I should say, will fit inside of a circle. Okay, and what we know about a circle is that the angle inside of the circle is 360 degrees. So just a little bit of math here first. So 360 okay, and I've done a line there and I'll explain why. What we're going to do is we're going to divide 360, which is the angle inside of the circle, divided by the number of sides that we need for our polygon. We're starting off with a pentagon, and we know a pentagon has 5 sides. So 360 divided by 5, that is actually equal to 72 degrees. Okay, and I'm just going to put in brackets there EXT. And EXT is going to stand for external angle. What that means is, for our pentagon to be constructed, all the external angles of our pentagon are going to be 72 degrees. Okay, so the pentagon is often probably the most awkward one, so you're going to actually have to use a protractor to draw your pentagon. Okay, so the way I like to do it is I just use my protractor. So the center of the protractor, I'm going to put it on the point here at the end of the line, and also on the point here. So I'm going to put the center of it on the point. I use it with the T-square. Make sure it's right on the point there. And what I'm going to do is I want to read around to 72 degrees. So I'm going to use the inner scale when I'm reading this way. So 0, 10, 20, 30, all the way up to 70. And I'm going to mark 72 right there. Just a little dot. Then I'm going to come to the opposite side, right over here. And once again, 72 degrees. So this time I'm using the outer scale. So I'm going around this way. 70. And there's 72. Another little mark there. And what I'm going to do now is I'm going to connect up my lines lightly, ever so lightly, to the angle that was created. Okay, and as you can see there, I have now done 2 light lines. These are construction lines, okay, because I know they have to be 50 millimeters long. So 2 ways you could do it. You could, I'll read it this way actually, sorry, I'm going to put 5 on the corner, so it's 50 millimeters, and just to make sure I'm 100% accurate, it's pretty close actually where the top of the protractor was, so that's 50 millimeters there, so I'll heavy in that side. Now, having done that, rather than measuring over on this side, what I'm actually going to do is just slide up my T-square there, and I should be able to do a line across, and that should give me the height on this side. So now I can heavy in the third side. Okay, so quite easy there. Another way we could have done it was simply taking a compass. Just setting up my compass here, taking the distance of 50 millimeters on our compass like that, and then going here and marking it as well. Okay, that would have worked as well. Okay, now The next bit is we have to get obviously 2 more points or 2 more sides up here to create the top of it. Now, one way we could do it is we could come along with our protractor, putting it on the side, making sure the center of it is on it. Okay, so you just see the center at the end of the line here, and it's zeroed on this side, and I would read around 72 degrees this way. So there's my 70, so 0 all the way around 70, 0.72 again. Okay, and that will give me the direction of the line going like that. I do the exact same with the opposite side. Okay, that's just using the protractor the whole way. However, the easiest way to do it is by taking your compass. We've already measured our distance of 50 millimeters. I can go to this point here. I'm going to swing an arc like that, and now I'm going to go to this point over here and swing an arc. Where the 2 arcs intersect one another, that is the top of my pentagon. Because both arcs are 50 millimeters away from their previous point. Okay, so there we have it. That is our regular pentagon completed. Just going to put in a little bit of helpful information there now. Just extending out that corner. I'll write this in here now. And there we have it. What we have here is our angle of 72 degrees. Okay, and that there is why I call it EXT. That is our exterior angle. EXT. That is our exterior angle. Now, by doing a bit of quick maths, we could actually work out our interior angle. So we know that any angle on a straight line, or the angle on a straight line, is 180 degrees. So there is my interior angle. So the angle on a straight line is 180. We've already got 72. So 180 minus 72, that is 108. And that is our interior angle. I might just write it like this, INT angle. And that is our interior angle. So all the interior angles of our pentagon will add to 180 degrees. And all the exterior angles, if I was to extend, just to show you here very quickly, I'm going to put in lightly. If I was to extend that line out there like that, that angle there, right here, is 72 degrees. The interior angle is 108. Okay, so there's our first one. That is our pentagon. To find out the exterior angle, 360 divided by the number of sides. Okay, now what we're going to do is we are going to move on to our hexagon here. Okay, so same principle, starting off with our little bit of maths. So I'm going to work it out here. So hexagon, 6 sides, so 360 divided by 6, that is equal to 60 degrees. So that is our exterior angle this time. Okay, now this one is a little bit easier in the sense that we already have a 60 degree angle on our set square. So we've got our 60 degrees here. So much easier this time. We don't have to use a protractor, which is a little bit more obviously time consuming. So 60 degrees from the corner, construction line first, and likewise turn it this way, 60 degrees from this corner. And what I'm going to do now is I'm going to measure out a distance of 45 millimeters. So measuring 45, so I measure 45 back to 0, right there. I'll heavy that in. Having measured it on this side, rather than going through the process of measuring it again, I can literally just slide this along, line it up with that side. There we have it. That is the opposite side done. that's 3 sides completed now on our hexagon. And at this point now, what I have to do is I have to get the top half of it. We've done the bottom half, we have to get the top half. So, what I notice here is that this side here will actually be parallel to this side. We know that the angle here was 60 degrees. So once again, going at 60 degrees. So very light line first. And same concept again on the opposite side. Parallel, it's going to be parallel. Hexagon has an even number of sides, which is 6. Now, a couple of ways I could do it here. I could take my compass, or just measure again. Could measure obviously 45 again. Could take my compass, and then mark it as well. Okay, like that. But possibly the easiest way to actually do this one, and it's a little bit of a time saver, down here should actually be the same as up on top. So if I was to extend the line up there, you can see it goes through the exact same point that I was previously on. So if I was to extend the line up like that, very lightly, gives me the top point there. From that point then, it's very easy for me literally just to go like this, straight line across, can heavy that in, and now I can heavy in the rest of my pentagon, sorry, hexagon. Okay, so there we have the hexagon done. Once again, just going to put in this bit of information here. So that is the exterior angle, and that will be the interior angle. So we know 60 degrees, 120, because a straight line 180, 60 from 180 leaves 120. So that is the exterior angle, and this is the interior angle. Okay, now finally we're going to move on to the last one, which is down at the bottom of the page. We have done a pentagon and we have done a hexagon, and the last one we're going to do is an octagon. Okay, and I'll just move it a little bit there so you can see it a little bit clearer. So octagon that has a side length of 40. Okay, so first of all our little bit of maths again, and we'll just complete it out here in the space here. So an octagon, 360 degrees divided by the number of sides, octagon, oct 8. Okay, 360 divided by 8, that is equal to 45 degrees. So that is our external angle. So the external angle is got by dividing the number of sides into the degrees inside of a circle. So this time, once again, kind of like the last time, what we're going to do is we're going to use our set square, which is very helpful in this case. We do not have to use, you could use a protractor, but obviously we've already got a 45 degree set square, so we're going to stick with that. Our exterior angle is from the corner, so I'm going to go at 45 degrees, lightly first, come to the opposite side, 45 degrees, lightly, and then I know the distance is 40 millimeters, so I'm going to measure out there a distance of 40. It's right to there. Mark that down, and from there, rather than marking it again, could do a line across like this. That'll tell me the height on the opposite side. Now I've got 3 sides of my 8-sided octagon, and now what I have to do is I have to go up vertically, and I'll explain why in just a second. I'm actually going to explain why, I'm just going to put in this bit of information as usual on the exterior and the interior angles. So that is the exterior angle, that is the interior, so we know the exterior angle was 45 degrees. That means the interior, 45 from 180 is 135 degrees. Now, that's going to be helpful up here in determining how we would actually get the next part of our octagon. Okay, to get the next part of the octagon, and I'll show you actually on this side, is because I'm actually going to go up vertical. And I'll explain why. I'm going to go vertical here. I would also have to do it from here, but I'll explain on this side over here. And I know that distance there is 40 millimeters. So once again, I'm going to measure a distance of 40. Okay, could have taken my compass obviously and taken that distance and just marked it up. So having marked the 40 millimeters there, okay, I can project that across the other side because it'll be the same height. So there's the 40 here. Okay, I've now got 5 sides, but just to explain why I went up vertical there, my internal angle is 135 degrees. If I was to extend this line out a little bit here, okay, we know that that line there is going at 45 degrees. This line has gone up perpendicular. Therefore, this angle here is 45 degrees. Okay, so the line up here was going perpendicular, whereas this line was going at 45 degrees. That makes the angle within here 45 degrees. This internal angle is 135. So at that point there, that's why we go up perpendicular. Now what we have to do is we have to complete the top half of it, or sorry, the top section of it here. Okay, which is going to be the exact same as the bottom section here, only obviously like flipped over. So once again, we're going to go 45 degrees, this time inwards. And then I'm going to do the exact same from the opposite side. Okay, I could have had my set square like this and just done it that way and then slide it over this way. Now to complete that, okay, I could measure once again 40, okay, and 40. However, it should match up with this line down here as well. So a little bit of a time saver here from this point here. Just do a line like that. Obviously it's a construction line, and at that point there now, there it's going to go straight across. So send that across, and there we have it. So just once again, heavy that in. Get that out of the way. And finally, I'll actually just put in this one. It should match up with this guy, and I can see it does. So I know I'm quite accurate there then. So what we can actually see there, guys, is the octagon completed. And you can actually see how kind of all the corners match up with almost the opposite side. Okay, which actually makes it quite helpful. Once we've done kind of one measurement, we can almost figure out the rest of it. It was very similar up here, obviously, with the hexagon. Just showing you there. This corner should have matched up with this corner at the top, and it does. Okay, so for the ones where it is even numbers, the octagon and the hexagon, that's probably a little bit more helpful. Okay, so there is our 3 types of polygon drawn. We have a pentagon done, 360 divided by the number sides 5 gave us an exterior angle of 72. Hexagon, 360 divided by the number sides 6 gave us an exterior angle of 60 degrees. And finally the octagon, 360 divided by 8 gave us an exterior angle of 45 degrees. Okay, from that we were able to work out the interior angles. Now the last little bit, okay, just on getting maybe the centers. Okay, so if I wanted to find the center of a hexagon, okay, I'll come to this one at the very end. But if I wanted to find the center of a hexagon, what I could do is simply join the diagonals. I'll put these in just in red. We can actually see right in there, because I had this diagonal technique connected already. Okay, you can see there that is actually giving us the center. Now if I wanted to find the center of my octagon, could use the same principle. Okay, so this side here and this side, I could join the diagonals. Likewise, I've actually got a little square inside here, and if I was to join that to that, it should go through there. That's another way of finding it. Okay, and you can see it always goes through it there. So we actually have our center there. Wouldn't usually use the square. It's generally kind of join this one to this one, this one to this one. Quite helpful. Or vice versa, here to here and here to here. Okay, so that's finding the center there. Now on the pentagon, how you actually do it is you can either bisect the sides, okay, and where they cross each other, that will give you the center, or bisect the angles. Okay, so just on that, what I'm actually doing here is I'm going to bisect the angle. So just to show you there, when I connected the corners, okay, the opposite sides, really because that was 120, I was going at 60 degrees, that was actually helping me bisect the angle. So to get the center of my pentagon, what I'm actually going to do is I'm going to bisect any two of the interior angles, and that should help me actually find it. The reason it doesn't work out as neat maybe or as easily as these two is because it is an odd-sided figure. Okay, it's got 5 sides whereas these had 6 and 8. Okay, so what I'm going to do is I'm going to bisect any two angles. Now the easiest one to actually bisect is the top one. Okay, and the reason for that is because I can just go straight down. Just somewhere along there is going to be the center. Now the other angle I'm actually going to bisect is this one. So very quickly I'll bisect that there. A little bit of practice in our bisecting of angles. So compass point, I'm going to arc here, cut this line, likewise there. Then I'm going to put my compass point where I cut the line. So you can arc on the inside. The exact same there. And what I do then is connect where the two arcs cross each other back to the vertex, and there we have it. That is our center. Okay, so now I've got the 3 centers. I've got my center of my pentagon, my hexagon and my octagon, and at the very start I told you that all of these polygons fit inside of a circle, and hopefully, depending on my accuracy, just to be able to prove it. Okay, I've now found the centers. So the center to any vertex should be your radius. So I'll start with the pentagon. Just going to put compass point on the center. Out to any vertex here. See how we're getting on. Let's make sure first. I'm pretty sure that's alright. Not bad there. A little bit of inaccuracy down here at the corner, just a tiny bit out. I'll take that. Next one. Here we go. Hexagon worked a little bit better, as you can see, fits inside it. And then finally we're going to go down to the octagon. There we have it. Okay, there is our 3 polygons, our pentagon, our hexagon and our octagon. The construction of how you complete each one of them, and just to show you again how you find the centers, and then using the centers then to draw the circles around them. Okay, hope you found that helpful, guys. That is polygons.